Hi everyone, today we're going to do chapter 4.1 and 2 of your textbook, Similar Figures and Scale Factors. So if you can turn to your textbook, page 133, and pull out your notes that I have on the Andy page, we can get started. So first off, where would we use similar figures and scale factors? Architects, engineers, designers, surveyors all use plans for their works. Plans for building roads, bridges, furniture, machines will all be detailed on scaled diagrams. The scale will vary depending on the size of the project and the paper or screen it will be displayed on. Most will be reduced, however for machinery and small pieces it may be scaled up for a better detail. Plans can also be used to create scale models of designs as you're seeing in your textbook. Okay. Scale models are used in many industries: engineering, filmmaking, the military, architecture and model building. Okay, so 4.2. I'll get it to Chapter 4.2, Similarity of Two-Dimensional Structures. See page 134 of your textbook. Objects are called similar when they are exactly the same shape but are different sizes. Objects that are the same shape and size are called congruent. Scaled-down models play an important role in testing out a design. The model can be trialled and tested before a full-sized object is built. Two-dimensional objects are similar when their corresponding internal angles are the same and also when their corresponding side lengths are proportional. Proportional means that the ratios of the corresponding sides are always similar. In maths, we use the wave sign to show that similar objects. Okay, we're now going to go through worked example 1. Okay, worked example number 1, page 134. We're going to look at two objects that are similar. Step 1. Check that internal angles are the same. On the diagrams you'll notice the single line curved and the double line curved marks indicate that all the corresponding angles are equal. Please make sure you add that to your notes. All blue coloured notes you need to add to your notes. Step 2. Calculate ratio of the side lengths and then simplify your ratios. Ratio is equal to the large object length divided by the small object length. When we look at the two figures, that's going to be 12.5 over 5 and 5 over 2. Simplified down, both ratios come to 2.5. Therefore, the objects are similar. Similar triangles. There are three rules that can be used to determine if two triangles are similar. See diagram on page 135. We have the angle-angle rule, the side-side rule and the side rule. We're going to look at worked example 2 next. Worked example 2, page 135. Here we have two triangles and we need to determine if they are similar. First off, identify all possible angles and sides. So let angle X equal 180 degrees, subtract the two angles provided, 72 and 38, which comes down to 180 subtract 110. The unknown angle X is 70 degrees. If they're both similar and you have a look at the angles on the triangles, angle Y in the other triangle will be 38 degrees. In step 2, use one of the three rules to check for similarity. Because we're looking at angles, we're going to use the angle rule. All three angles of the two triangles are equal. The three angles are 38 degrees, 72 degrees and 70 degrees. Therefore, when we state our answer, the two triangles satisfy the AAA rule and are therefore similar. Which leaves you the final part of this chapter. You get to try exercise 4.2 in the following numbers. Thank you.